Okay, so today we are going to be doing day 5 of our notes. We are going to talk about converting with moles using dimensional analysis. And the mole is one of the most important conversions we have in chemistry, as we discussed when we were talking about measurements. The mole is the unit that we use to measure the quantity, the mole. And it is very similar to, we use it very similarly in the way that a baker might use the phrase a dozen. So when we say a dozen, a baker knows that means 12. When I say that I have a pair of shoes or a pair of socks, you understand that to mean 2. When a chemist says that they have a mole of something, they understand it to be 6.022 times 10 to the 23rd particles. So 1 mole is equal to 6.022 times 10 to the 23rd particles. Do you need a copy of notes? Okay, so you do not have to memorize this number. We will be using it in conversions. Just know that it is listed under your constants and conversions on your formula chart, right there, as Avogadro's number. This is because it is also known as Avogadro's number. And this number is extremely large. We use scientific notation to represent it because it is so large. And I have a nice video clip here that is a TED Ed talk that kind of impresses upon you how large this number is. So we're going to go ahead and watch that real quick. Those of you who are watching this video, you can follow the link and watch the same video I'm about to show in class. Okay, so we are going to go ahead and do an example with a conversion using this number, Avogadro's number. Here we're asked how many atoms are in 3.2 moles of platinum. So right now, since we haven't asked you to memorize all of your elements on your elements list yet, anytime we ask you for something having to do with an element, we will provide you with the symbol. So PT, that is the symbol for platinum. And we are asked for atoms in this amount of moles here, okay? Now, Avogadro's number says that 1 mole is equal to 6.022 times 10 to the 23 particles. A particle can be an atom, a molecule, or a formula unit. So right here for atoms, we use these when we are talking about elements. So since we're talking about an element like platinum, we will talk about the particles as atoms. If we were to talk about something, a particle for a covalent compound like water, then we would say molecules. And if we were going to talk about a particle for an ionic compound like salt, sodium chloride, we would use formula units here. So we don't need to know the difference between covalent and ionic yet. We will get to that shortly. At this point in time, we will also tell you what the particle is called, what your final unit should be. So again, how I like to start my dimensional analysis problems is write what we know. We know we have 3.2 moles of platinum. And I'm going to go ahead and write the number that we were given, 3.2, the unit, the mole, and the substance, platinum. Because this will become more important later in the year when we get into more complex dimensional analysis. It's going to be important that we keep track of what substance we are dealing with. So we're just going to get in that habit now and write our number, our unit, and our substance. So we have 3.2 moles of platinum, and we are asked to figure out how many atoms of platinum that is. So we are going to set up our dimensional analysis just as we learned to do last class. We're going to write our given first, 0.2 moles of platinum, and I'm going to go ahead and use parentheses to set up my conversion. Just like I told y'all last class, in terms of units, what goes up must come down. So in order to determine what's going to be in the denominator of this conversion, you just look at what your unit is up here. So we're going to take moles of platinum, put that unit and substance down there, and we are converting to atoms of platinum. So I have my units filled in, and now I just need to fill in my numbers. And again, we were told Now 1 mole is equal to this number of particles. So we're going to go ahead and put 1 with the mole, and we're going to write 6.022 times 10 to the 23 up with our atoms. And this is our one-step dimensional analysis to go from moles to a particle, like an atom. The moles will cancel out and leave us with our final unit. So we are going to do that calculation here. I'm going to go ahead and put myself in standard. Okay. So kind of hard to see with the glare on my calculator, but if we type this into our calculator, we're going to use the same rules we've been using for dimensional analysis, multiply everything across the top, and divide it by everything on the bottom. So 3.2 multiplied by 6.022. We're going to grab the big E using second x to the negative 1. That gets our big E key. And then we can type 23, because that big E will replace times 10 to the power of. If we hit enter, it will spit out our answer for us. Is this what I'm going to write down on my paper, though? No. What do I need to look at in order to figure out what I need to round this to? Sig figs, absolutely. So show me with your fingers, y'all, how many sig figs does our given have in this problem? Yes, 2. So, since our given 3.2 moles had 2 sig figs, we want to make sure that our answer is also in 2 sig figs. So we're going to go ahead and round this to 1 point what? 1.9, that's sufficient, correct. Times 10 to the 24, we want to make sure we do not forget this times 10 to the 24 here at the end, because if we leave this off, it completely changes the value of our number. We do not have 1.9 particles, we have 1.9 times 10 to the 24 atoms. So that is our final answer. Again, your final unit should match whatever is in the top right of your dimensional analysis there. What questions do we have about that first problem, that conversion? Okay. The second example here, we're going to do this one because I think it's a similar process, but I think it's good to see what we can abbreviate formula units and molecules at, because people always ask me, can I abbreviate formula units and molecules? Yes, you may. I will show you the abbreviations for them. So right here we have the question, how many formula units are there in 7.55 moles of sodium sulfate? And again, we have not learned how to name our compounds yet, so if you are given a name of a compound, you will be given the formula or vice versa. So right here, again, we are told we have 7.55 moles of sodium sulfate. This is the formula for that. And we're trying to figure out how many formula units are there in sodium sulfate. So, to abbreviate formula units, you can write F period, U period. So, yes, you can write FU to abbreviate formula units. I know it is very fun to write this, but keep in mind that you should only use it when you are abbreviating formula units. So if I'm asking you for atoms or molecules, please do not write FU on the paper, because I will take off half a point for the unit. So, we are looking for the formula units of sodium sulfate. So we can abbreviate it like that, because I know that is kind of a lot to write out every single time. So I want you, knowing what you know about dimensional analysis and the conversion that I just told you, 1 mole equals this many particles, to try and attempt this example. And then we will check our work as a class here in a second. Let's go ahead and go over this. We started out with our given. I went ahead and set up our skeleton of our problem with our one-step conversion. Started out with our given. Knowing that this is our given, what unit are we going to go ahead and put here in the denominator of this conversion? Yeah, it's going to be mole. I'm going to put mole, and we're converting to what in this case, y'all? Formula units. So we can abbreviate that as FU. Sodium sulfate. Kind of squeezing in my sodium sulfate there. So what number goes with mole, y'all? 1. And what number with formula units? Yeah, 6.022 times 10 to the 23, Avogadro's number. Again, that is on your formula chart. You should always know what this number is. By the end of the year, we will be using this so much you will have it memorized. But you don't need to memorize it. So we're going to go ahead and multiply these together. Can anyone tell me what they got for their answer with the correct number of sig figs? Yes, sir. 4.55 times 10 to the what? 23rd? 24? Okay. Thumbs up, thumbs down, do we agree? Yeah, I agree with that too. And our unit, formula units. Very good. Okay, nicely done, y'all. What questions do we have about going from moles to particles? Okay. We're going to go ahead and do a particle to mole conversion then. We're going to go from molecules to moles, and we're going to learn the abbreviation for molecules. So, okay, so our question here asks us how many moles are there in 8.24 times 10 to the 26 molecules of water. So again, I'm going to go ahead and write out what I know. For molecules of water, you can abbreviate it MLCL. I've also seen it abbreviated MLC. Please, when you are abbreviating molecules, do not abbreviate it as MOL, because MOL is for the mole, not for molecules. Please do not abbreviate it as ML either. What is ML, y'all? Milliliters. We don't want to say that we have milliliters of water. We have molecules of water here. And what's the chemical formula for water, y'all? H2O. Yay! We learned something in biology. Awesome. And just being alive. So our molecules of water, we are curious about how many moles make up that many molecules of water. So we're going to, again, set this up as we would any other dimensional analysis. We're going to write our given first, 8.24 times 10 to the 26 molecules of H2O. I'll use train tracks this time for those of you who are fans of the train tracks. And what are we going to have as our unit down here if we are starting out with 8.24 times 10 to the 26 molecules? Molecules of H2O, absolutely. We want to make sure those units cancel out. What goes up must come down, so we're going to take that unit and put it right there. And when we go from molecules, we're going to then go to, what are we asking for here? Moles. We want to know how many moles of water. And we can go directly from molecules to moles, because molecules are a particle. So what number goes with mole? 1. What number goes with molecule? Avogadro's. Nicely done, y'all. So we fill that in, and then we can go ahead and do that in our calculators. So I want us to practice typing that into our calculators, and then we will share answers as a class. Okay, so hopefully we're able to type that into our calculators. Does anyone want to share what they got with the correct number of sig figs? Any ideas? Yes, ma'am. 1.37 times 10 to the power of 3. What do we think, y'all? Thumbs up, thumbs down? We agree? Do we disagree? There's no thumbs up, thumbs down. Y'all tell me, do you agree or do you disagree? I hope you typed it into your calculator. Yeah, thumbs up. I agree with that. And what was our unit here? Yeah, moles. So our molecules will cancel out and give us moles of H2O. Did anybody else write it a different way? Yes?
I just wrote it
1,370. Is that also 3 sig figs, representing the same number? Yes, you can write this either way. So, if you were in scientific notation mode, your calculator would spit it out like this, and you could round to 3 sig figs, 1.37 times 10 to the power of 3. However, if you were in standard mode, you could also see 1368, okay? So to round, that is the same, these are the same number. This is just in scientific notation, and this is in standard notation. So you can represent it either way. I would accept either on an assessment. Do we all see that? Do we have any questions? Yes, sir.
So to find the mole, would you just multiply 8.34 and then multiply 8.34?
So right here to find the moles, because this is up on the top and this is on the bottom, we're going to have to do this divided by this. So our rules for dimensional analysis, it says that we have to do this times this, which will not change the value because multiplying by 1 will not change our value, and then we will divide by what's on the bottom. Yeah. Any other questions?
And then what is it? It was 1368, right?
Mm-hmm.
And divided to 1370.
Mm-hmm.
Is that for significant?
Yes, for significant figures. So if I wrote 1368, how many sig figs is that? 4. So in order to round it to 3 sig figs, we went ahead and rounded that 6 up to a 7, and that 0 is not significant since we don't have a decimal in this number.
8.34.
Yes, this is 3 sig figs right here. Remember, for our scientific notation, we only look at the significant figures in the coefficient. Yeah. Any other questions? Okay, nicely done. So we're going to go ahead and move on to conversions with the metric system on the next page. You can do this later for practice if you'd like. I have the key if you would like to check it. But we're going to convert with the metric system. So please do not get intimidated by this extremely large chart. You're not going to have to memorize this whole chart. There are a couple that I do want you to memorize. I will let you know which ones I want you to know. But as you have probably seen, based on our conversations about the international system and the metric system, the United States, typically in our everyday lives, going about, when we're not doing science, we tend to use a different system. But in science, and especially in science class, we like to use the metric system because everybody else uses the metric system in science. So we are going to use this system and learn how to convert within it using dimensional analysis. The ones that you have to memorize, you do not have to memorize all this giant list in that green table. You do need to know these 5, though. So I want you to be familiar with the prefixes kilo, centi, milli, micro, and nano. And I will point out that milli and micro do use different symbols. So this micro, that's the Greek symbol for mu, the letter. So milli is that lowercase m, and micro kind of looks like a fancy m. If you do not remember that on an assessment and you are freaking out because you can't write, micro or something, it's okay. When in doubt, write it out. It's perfectly okay to write microliters or micrograms out if you forget this symbol. But I do not want you to write mg for micrograms because that is milligrams. So just a little disclaimer ahead of time because I've seen that happen. So these, I want us to memorize the scientific notation that goes along with this. What this is telling me, as if I have a kilo of something, so like a kilogram, a kiloliter, a kilometer, kilometer, I have 1,000 of my base. So, for example, 1 kilometer is equal to 1,000 meters. Same thing as writing, right here, 1 kilometer is equal to 1 times 10 to the third meters, because 1 times 10 to the third is 1,000. So these conversions are saying the same thing. This is just our nice, easy way of, especially when we get into some of our conversions like micro and nano, it gets to be quite a pain to write all those zeros out, so we just use that scientific notation. These prefixes right here, kilo, centi, milli, micro, nano, these are never used alone. They're always attached to this thing, a metric base unit, okay? So our metric base units are going to be things like liters, grams, meters, joules, and pascals, okay? So we're going to be using kilometers or kiloliters or kilograms. We're not just going to say kilo because that's not specific enough for our purposes. And when we use these scientific notation equivalents in dimensional analysis, there are special rules about which, unit it goes with, okay? So when we set up our dimensional analysis conversions, our fractions in our parentheses or in our train tracks, we are always going to put the number 1 with our prefix, okay? Number 1 always goes with our prefix. And I always remember that 1 goes with our prefix because the prefix is the first part of the word. It comes at the beginning of a word. So since it is the first part of the word, we're going to put a 1 with anything that is a prefix, like kilogram or centimeter or whatever we have. Our scientific notation over here that we have in this chart, that is always going to go with our base. So when we're setting up our dimensional analysis conversion and we have a base like grams or liters or joules, we are going to put this scientific notation equivalent with that value, with that unit. Okay, so this is going to make more sense once we start doing metric conversions on the next page. But does everybody have that down? Okay, so we're going to flip to the next page. We're going to learn how to do metric prefix to base and vice versa conversions, okay? So these, if we're just going to go from a metric prefix to a base or a base to a metric prefix, these are going to be one-step dimensional analysis problems. So I'm going to do this 2 examples with you. So I'm going to do a metric prefix to base and a base to metric prefix conversion with you. This first one asks us how many meters would be equivalent to 32 nanometers. So again, I like to write out what I know, 32 nanometers, and what I'm trying to figure out. In this case, meters. Somebody asked me yesterday, do I have to write this out to get points? No, you do not. I just think it's a good way to kind of organize our information in our word problem. So use that as you wish. You do need to write out your whole dimensional analysis to get your full points. So we're going to do what we did previously. We're going to write our given first, 32 nanometers, and we're going to set up our conversion. I'll use parentheses here. And so the same rules apply for how we organize our units in our conversion, okay? What goes up must come down. So we're going to go ahead and take nanometers and put it in our denominator here. And we are trying to convert to meters in this case. And I told you that metric prefix to metric base is 1 step. We can do that in 1 step with 1 parenthesis. Now this is where our rules for prefix and base come into play. So I told you that there's a number that always goes with the prefix, and that number is 1. So we look here and we find the one that has our prefix. Nano is the prefix here. Meters is the base. So we're going to put 1 with the prefix. And then we're going to put our scientific notation with our base. So if we go back to our chart that we probably haven't memorized yet because it's been 2 minutes, we have nano and we have the scientific notation that is associated with nano. 1 nanometer is equal to 1 times 10 to the negative 9 meters. So we get to put 1 times 10 to the negative 9 with our base, meters, and we have now set up our dimensional analysis. And so I want us to practice typing this into the calculator because we have a negative exponent here, and sometimes people get tripped up by that. So we have our given 32, we're going to multiply it by this and divide by 1, which is not going to do anything. So we're just going to multiply these 2 together. So 32 times 1, grab that big E key, and when we go to type in negative 9, I want us to make sure we are typing using this negative symbol right here, not subtraction, so we don't confuse our calculator. So we're going to grab the negative, we're going to type 9, and we're going to hit enter. And we get this really, really, really small number. What do you think I would prefer you to write this number in, y'all? Scientific notation, absolutely. Don't do that to yourself. Don't make yourself write all the zeros out. So, again, as another review, to get into scientific notation, we're going to hit second DRG. That pulls up this screen. And we're going to arrow over to SCI. That is scientific notation display. We're going to hit enter, and our calculator will put it into scientific notation for us. And we are lucky here, too, because look at that. It already matches the sig figs, too, right? We had 2 sig figs in 32. And our calculator gave it to us in 2 sig figs, so we don't even have to do any rounding. Just make sure that you include that times 10 to the negative 8. And what is our final unit, y'all? Meters. Yes, sir, what's your question?
So like when you went from low to high, right?
Mhm.
Like your thing says 3.2 times 10. Mine has like 3.200000000 times.
Oh, really?
Yeah.
Interesting. Okay. If your calculator does spit out 3.200000000 times 10 to the negative 8, then you will need to round to the correct number of sig figs. And so you just need to take off those zeros, because since there's a decimal, those zeros are significant. So please do not write, 3.2000, for example, because how many sig figs is that, y'all? 5. So we don't want to do that. We want to make sure our number of sig figs in our answer matches our sig figs in our given.
My thing says 6 at the bottom. You don't fix it.
Oh, that might be the issue. Okay. For that, just to reset your calculator, hit, if your calculator's ever giving you issues, y'all, just a pro tip, hit second and this 0 to reset, arrow over to Y, yes, it will clear a memory, and it should just put you back into standard display and should get rid of anything else there at the bottom. Yeah. Okay. Any other questions? Okay, so we're going to go ahead and do example 2 right here. This one asks us for the number of microliters in 4.56 times 10 to the negative 3 liters. So again, I like to just organize myself, write what I know, that I have this many liters, and I'm trying to find microliters. And remember, we use that fancy symbol for micro. If you don't remember it on an assessment, write it out. When in doubt, write it out. But I'm going to abbreviate it because that's just less time. Okay. So again, same thing. We're going to write our given. I'll use train tracks this time for those of you who are train tracks fans. So we start out with liters. What unit is going to go down here on the bottom of our conversion? Liters. And what are we trying to get to? Microliters, yeah. So we're going from liters to microliters. What number do I get to put with liters, y'all? Yeah, scientific notation will go with liters, because liters is what? It's a base, absolutely. So we're going to use our scientific notation. Does anybody want to tell me what the scientific notation associated with microliters is? Yes, ma'am. 1 times 10 to the negative 6. Very good. Please have that memorized by your assessment, y'all. And then microliters, what number do we get to put with that? 1. 1 with our prefix. And we have set up our conversion. So we're going to go ahead and do that division. Again, be very careful typing this into your calculator, using that negative symbol, not your subtraction. Divided by the negative 6. And you get, if you are in standard notation display, this value. How many sig figs are in this value, y'all? 3. How many sig figs were in our given? 3. Are we good to write this down as our answer? Did anybody get it in scientific notation? Do you want to share? Yeah. No? No. Anyone want to share in scientific? Yes, sir. 4.56 times 10 to the what? Negative 7. It's not negative 7, so retype that in your calculator, see if you do something. Yes, ma'am. 10 to the power of 3, yes. So this is going to be equal to this. Make sure when you are typing this into your calculator, you're very careful about what buttons you're pushing. It might cause an issue with that final. Okay. So there we go. So if you had given me either of those, I would accept those as answers, because they are both the same number. Okay. What questions do we have about, box that too. What questions do we have about going from prefix to base or base to prefix? Good, we're solid, awesome. Then we're going to add a little more complexity to it. The last thing on our notes, we are going to cover metric prefix to prefix. So if you're going from prefix to prefix, these are going to require 2 steps. And it's going to require 2 steps because if we're going from something like millijoules to kilojoules, we are going to have to convert through our base unit. So you can see in the example that they've given you here, converting from millijoules to kilojoules, that they first converted to joules, and then they converted to kilojoules. So we're going to have to do that if we are ever given a prefix and a prefix conversion. Yes, ma'am? So I want you to go to the base unit first because I don't want you to memorize prefix to prefix scientific notation. I want you to memorize like prefix to base, the scientific notations associated with that. You could technically, if you have knowledge of, how many places these prefixes are representing, do that. But it's going to be easier in the long run. It's going to keep us practicing that dimensional analysis by just going to that base unit first. Good question. So yes, please do go to that base unit. Treat this as a 2-step problem. Okay. So we're going to do the example 231 centiliters to nanoliters here. Again, I like to be really thorough. Nanoliters. So we're going to write out our given 231 centiliters. And then we're going to set up our 2-step, because we know it's 2 steps because it's prefix to prefix. And so what unit gets to go down here in the denominator in our first parentheses, y'all? Centiliters, CL. And we're trying to go from our prefix to our base. So what is the base in centiliters, y'all? Liters. So we are first going to convert to that base. What number gets to go with liters? So scientific notation or 1? What do we think? Scientific notation, yes. This is our base. Scientific notation always goes with our base. So if we see the scientific notation associated with base and centi, it is 1 times 10 to the negative 2. So we're going to fill that in. Sorry, I just wrote it in the wrong spot. 1 times 10 to the negative 2 goes with our base, liters. And what number gets to go with our prefix? 1. 1 always goes with our prefix. Okay? So there's our first step. If I stopped right here and solved this, what unit would I be in, y'all? Liters. Yeah, but we don't want to go to liters. We want to go to nanoliters. So we are going to do that second step. We have canceled centiliters. So what unit gets to go down here? Liters. And what are we converting to? Nanoliters. Perfect. Okay. Again, what number is going to go with nanoliters? 1. This is our prefix. Nano is a prefix. We're going to put 1 with our prefix. We're going to put our scientific notation with liters. Does somebody want to tell me what that scientific notation is? Yes, sir. 10 to the power of 9. Yes. So we're going to do 1 times 10 to the power of negative 9, to be more specific, because nano is very, very small. And now we've set up our problem. We can multiply everything across the top and divide it by everything on the bottom. So this times this divided by this. So I want you to try that. Practice typing that into your calculator. Very careful typing that in. Make sure we use our negative symbol when we are putting in those negative exponents. Okay, would anyone like to share what they got for that? Yes, sir. 2.31 times 10 to the negative 9?
Yeah.
Do we agree with this? Thumbs up, thumbs down? What do we think, y'all? Did you forget a negative somewhere, maybe? Somebody else got something different? What did you get, Peter? 2.31 times 10 to the 9? What about now, y'all? Do we agree with that? Thumbs up, thumbs down? So it should be 2.31 times 10 to the 9. If you got to the negative 9, double check that you typed in everything correctly with your negative exponent. And then our final unit is going to be what? Nanoliters, yes. Okay. Yes, sir.
Would you multiply the 231 with the, divide 231 divided by, 10 to the,
So you would do this times this. So everything across the top, we're treating this as like this is over 1. So we're going to multiply this by this, and then we're going to divide the product of those two numbers by 1 times 10 to the negative 9. Does that make more sense? Everything across the top gets multiplied and then divided by everything on the bottom.
So you multiply everything that's on the top and then divide it by the bottom?
By the bottom, yes. Were you able to get the to the 9 power, or was it?
No, I was doing what you're saying.
Weird. Let me see. Okay, so 231. Are you in like scientific notation and degree, not like another weird mode? Okay. 231 times 1 big E to the negative 2. And then divide it by EE negative 9. Should give you...
No, I didn't.
Okay. Any other questions about that one? Oh, okay. Then I want you to go ahead and try the second one. And then I will put up the answer so you can check your work. Okay, so there is the answer to that problem with all the work shown. So double check yourself, make sure you did that correctly. And once you finished that, you can move on to some of the other examples. We had some examples we skipped. Those are extra for you to practice. I have the key if you'd like to check those. You can also begin working on that practice worksheet. If you have some of the practice worksheet, you should be able to do all of your practice worksheet now with what we have learned, and get ready to take those skills checks and study for that test.